So let's say you're given these two things, and we've done things like this before, but the question is like, which one's the more reactive base? And so then you got to remember what a base is. Of course, a base is something that's electron rich. When you say base, usually that means they're going to go grab a hydrogen, so you're probably looking for negative charges or lone pairs. And so in this case, we're really talking about both these cases. This is pyridine. We're talking about the nitrogens, specifically the lone pair of the nitrogens. And what's the same and what's different about these? So obviously, they're both nitrogens, so that's not different. But what is different? The difference is the hybridization state of each. So the hybridization state for this nitrogen is sp2 hybridized. The hybridization state for this nitrogen is sp. So the reason why that's important is because it helps us understand what kind of bonds this atom has and where its lone pairs are located, what kind of hybrid orbital the lone pair is located in, and that'll help us understand how they're going to react. So in this case, this nitrogen, sp2 hybridized, its lone pair, which of course I know you know, is located in a sp2 hybrid orbital, which means it's not doing resonance, right? Because you have to be in a p orbital to do resonance. This lone pair is in an sp orbital, also not doing resonance, right? Okay, so that's great. How does this matter? Well, then you can look at what's interesting, sp and sp2. The shape is different. sp2. So the difference between sp2 and sp is the shape, right? So there's sp2-ish, sure. And there's sp. So what happens is when you try and think of the reactivity of this, you're really trying to think of the reactivity of the lone pair. So the lone pair is in here versus the lone pair in here. If the lone pair is in here, it's closer to the positively charged nucleus, which contains protons, which makes it less reactive, right? It's being held tighter by the nucleus, versus the longer hybrid orbital sp2, which is farther from the positively charged nucleus. So this would be more reactive. So this would be a more reactive base. So this is an example of hybridization state affects reactivity, right? And now you can think of the same thing about nucleophiles, right? Which one? So right, you can say which one of these is a better nucleophile? Well, it'd be this one because again, its lone pair is in a hybrid orbital that's farther from the positively charged nucleus, so it's more likely to be reactive. So the question is, what if it's in a p orbital? But is it in a p orbital meaning it can do resonance? So if it's in a p orbital doing resonance, then it's going to be less reactive because now the lone pair is doing resonance instead of reacting.
But compared to like sp2 to sp,
It'd still be less reactive because it's doing resonance probably.
what would be less reactive?
So like, if a lone pair is in a p orbital and it's doing resonance, it'd be less reactive probably than these. So if it's neutral, so if I'm doing, no, I'm winging it. So let's see. Like, is this lone pair, because this nitrogen is sp2, and that lone pair is in a p orbital, is that lone pair less reactive than the sp? Probably. That's not like that's a tough question. That's a tough one to answer because you're kind of now you're changing you're adding another factor into it of resonance.
Oh,
right?
So it's like if
So
one
now,
resonance is better than the other.
yeah, well, no, is resonance more important than hybridization, than like this? So what factor is more important? This doing resonance or this being farther from or closer to the nucleus? Right, so it's hard because now you're comparing two factors, hybridization state and resonance. It's like once you start trying to compare like multiple things like that, then things get a little bit harder to like discern. So then you have to run the experiment. So you try to ask questions like that, or if you do ask questions like that, you say, well, wait a second, well, this one can do resonance, this one can't. So I don't, you kind of start hemming and hawing about ideas and justifications either way.